everyone, and welcome to a discussion of sets and intervals. In this video, we're going to look at the difference between an intersection and a union, and then we're going to use those to find different sets. So let's take a look at what an intersection and a union is. If you think about the word intersection, we use that word to mean a place where two things cross. For example, in this picture of the roads, the intersection is the place where the roads cross. So we're looking at what they both share. And that's what we mean when we're talking about sets. We want the elements that are in both sets. When we talk about a union, we're talking about everything working together. So we want everything in both sets. But if things are repeated, you only include it once. So we're looking at uniting everything together, bring it all together. So let's take a look at some examples so you can get the idea more clearly with how this would relate to mathematical sets. In our first example, they've given us three sets, set S, set T, and set V, and they want us to find the union of S and T, the intersection of S and T, and the intersection of S and V. So let's look at the union of S and T first. So set S is these numbers, and set T is this group. Notice the 4 and 5 are in both sets. So when I unite them, I list all of the numbers, and only 4 and 5 get listed once. So this is the union of both sets. We include everything that's in both of them. Now let's look at the intersection of these two sets. Notice in set S, there is a 4 and a 5, and in set T, there is a 4 and a 5. That is our intersection. Those are the only ones that are included in both sets, so that's all I list in my intersection. Now finally, let's look at the intersection of S and V. Set S is the numbers 1, 2, 3, 4, and 5, and set V is 6, 7, and 8. They don't share any numbers, so this is what we call the empty set. So we would use this notation. Now let's take a look at more with this, but in our next example, we're going to look at interval notation and inequalities. In this example, we're given the intervals from 1 to 3, not inclusive, and from 2 to 7, inclusive. So you'll notice I have some graphs of those down here. Now in the first one, we want the intersection of these two sets. So we're looking for what they both include. Now notice, this set starts at 2. This set includes 2. This one can equal 2, this one can also equal 2. So that's where I'm starting, is that 2 is included in both. And then both sets go all the way up to 3. 3 would be included in the bottom set. 3 is not included, but it is going all the way up to 3. So that's going to help me create my intersection. So I want all of the numbers from 2 to 3, not including 3, but including 2. And I would write that in interval notation like this. Now for the other one, they want the union of this. So notice this starts at 1, not including 1. It goes all the way up to 3. Now part of that is included down here, but this one goes beyond that all the way to 7, which is included. So I want the numbers from 1 to 7, where the 1 is not included, but the 7 is. And I would write that in notation like this. So I hope that's helpful and it helps you understand intersections and unions better.